This last example is not in your notes, but I wanted to add it because this will help you with the last problem on the derivative review worksheet. When you go to calculus, those of you going on to calculus, you will encounter this particular limit definition whenever you're trying to derive a derivative function for some new type of function, because we can have derivative functions for things other than polynomials. The power rule works for polynomials, but other derivative rules are needed for, say, exponential functions or sinusoidal functions or other types of functions. And so I want you to be familiar with how to use this formula. Even though we have a simpler way to do it for polynomials using the power rule, we are going to do an example or two more of how to use this limit of the slope formula in order to find the derivative function for a polynomial. So recall from previous notes that we are going to try to find the tangent line, or the function that tells us the slope of the tangent line, to the point x, f of x, on this function f of x. And in order to do that, we pick another point really close to x called x plus h, where h is just a little bit more than x. And it has a corresponding y value of f of x plus h. So I basically have 2 points. As the x plus h point moves closer to the x point, then that slope of the tangent, that slope that I'm using to approximate the tangent line, gets closer and closer to the actual slope of the tangent line. We say this using limit notation, that the limit as h goes to 0 of our slope, y2 minus y1 being f of x plus h minus f of x, and x2 minus x1 being x plus h minus x. As h goes to 0, this slope gets closer and closer to the slope of the tangent line. However, in order to find exactly what it is, we'd have to plug in 0 for h, in which case we would get 0 over 0. So we have to actually go through the process of expanding out f of x plus h, subtracting f of x from it, canceling out a common factor, and then taking the limit again. And that's what we're going to do algebraically now, using the function f of x equals negative 3x squared plus 5x minus 1. Before we get started, let's use the power rule just to show what we hope to end up with at the end. So the power rule says that f prime of x is equal to negative 6x plus 5. So that's the derivative function that we should find at the end of this process. Now, in order to use this formula, I have an f of x. That's this whole function right here that I can substitute in for f of x. But I also need to be able to substitute something in for f of x plus h. So let's write down what f of x plus h is. To find x plus h, I merely substitute x plus h every place there is an x. So we have negative 3 times x plus h squared plus 5 times x plus h minus 1. And we're going to substitute that in for y2 in our formula. So you're going to need to write small as we go across here. We start out by saying f prime of x is equal to, and I'm going to get up here so we can just see our limit definition, the limit as h goes to 0 of f of x plus h. So that means I'm going to write all of this in, which is negative 3 times x plus h squared plus 5 times x plus h minus 1 minus f of x, which is all of this function. So minus, and this is really important, put the f of x function in parentheses. If you do not put it in parentheses, you will not subtract correctly. So use parentheses, use parentheses, use parentheses. Did I mention that you need to use parentheses? Please use parentheses. As Paul says in the scripture, it bears repeating. Sometimes you have to be reminded of important things like that. Let's go on now. F prime of x is equal to the limit as h goes to 0. And now I want to do some simplifying in the numerator. So let's expand out. I'm going to have to expand x plus h squared, so this becomes negative 3 times x squared plus 2xh plus h squared plus 5 times x plus 5 times h, distributing the 5, minus 1, and then minus a negative 3x, which becomes plus 3x squared. So minus a negative 3x squared, plus 3x squared, minus 5x, and then minus a negative 1 becomes plus 1. I'm getting close, but not completely done here. And in the denominator, I have x plus h minus x. Now, f prime of x is equal to the limit as h goes to 0. One more thing to do is I need to distribute the negative 3 here. So I have negative 3x squared minus 6xh minus 3h squared plus 5x plus 5h minus 1 plus 3x squared minus 5x plus 1 all over the quantity x plus h. That's really sloppy. I'm going to get rid of that black line that I just drew and draw it a little straighter. There we go. X plus h minus x. Now I want you to notice something important about what we just got. If I simplify the numerator and the denominator, you will notice here that every term that does not have an h in it will cancel out with its opposite. So if we look in the numerator, we have a negative 3x squared and we have a positive 3x squared. Those add to 0. We have a positive 5x and a negative 5x. We have a negative 1 and a positive 1. In the denominator, we have an x and a negative x. When you look, every single thing that's left over has an h in it, and that's important for us to be able to cancel out our common factor in just a minute. So f of x equals the limit as h goes to 0, and I am stressing notation. Make sure you do not get careless and leave that limit notation out of what you're doing. In the numerator now I have negative 6xh minus 3h squared plus 5h all over h in the denominator. Now notice, any time in this process, if I tried to plug 0 in for h, I would get 0 over 0, and I still get 0 over 0. I still get 0 minus 0 plus 0 over 0. But now I can factor out an h, so that's going to allow me to eliminate this discontinuity. If I factor out an h in the numerator, I get negative 6x minus 3h plus 5 in parentheses, and I can cancel out that h I factored out in the numerator with the h in the denominator, and now I can plug in 0 for h in order to take the limit. So this ends up being that now f prime of x is equal to negative 6x minus 3 times 0 plus 5, or negative 6x plus 5, which is what I wanted to end up with before. Yay! Happy smiley face. I'm so glad that I got negative 6x plus 5, because if I hadn't, I would have done something wrong. So this hopefully will be helpful for you when you approach a problem like this. Remember, this is the way to find the derivative function using just variables. If I want to find a derivative at a specific value, then one of the points I plug in is f of x, and the other is a particular x and y value. So this is a slightly different example than what we did earlier with like putting in negative 2 and 20 or something. Hopefully this is helpful, and this is all of the intro to derivative notes now.